Alright, this is our last lesson. And we're going to talk about factors that affect the rate of reaction. In the last class lesson, we talked about how to plot a reaction curve. And basically, you're going to have a reaction that starts from time 0, and it's going to increase really rapidly, and then decreases as you go out, and it plateaus out, right? Something like that. In this lesson, we're going to talk about the 4 factors that affect the rate of reaction. And the 4 factors are surface area, temperature, concentration, and the use of a catalyst. Alright, let's start with surface area. So, imagine that there are 2 substances, alright? And they are of the same volume, and they are the same mass, okay? But one of them, you cut into 2 separate pieces. There you go. Slice it in half. And what you're going to see is that the surface area for the original cube is about 24 centimeters square. And the other one that's sliced in half, you have a surface area of 32 centimeters square. And I did the math over here. Each side here is about 2 centimeters, and since a 6 side to a cube, you have 6 times 4, which gives us 24. Here, we cut them into 2, so there's 4 sides with 4 centimeters square, and you have 8 sides that are 2 centimeters square. You do the arithmetic, and you should get 32 centimeters square. Now, because reactions only occur at the surface, alright? Exposing more surface area by cutting it in half, or even smaller pieces, you expose more surface area, then that means that more substances are available to react. So that is why you will see, by exposing more surface area, by cutting things into smaller pieces, you will see the rate of reaction increase. And in the class, you'll be able to do some experiments in testing how different materials of the same mass but different sizes will affect the rate of reaction. Okay, moving on. Temperature. We all know that temperature affects the movement of particles, of the substances, the reactants, all right? For example, at 30 degrees, what you're going to see is that the substances will move at this length of speed. It's just arbitrary, but let's just go with it. And you're going to see some of them have successful collisions, all right? For example, this guy, and then maybe this guy, and then let's say this guy, doesn't really collide, this guy here, this guy there, and you'll have some successful collisions, okay? But let's say if you increase the temperature by 10 degrees, the rate of which the particles move are now much faster. It's going up. Gain more kinetic energy, right? The particles have gained more kinetic energy. So even stuff that are far away before are now able to collide because of the rate of reactions, right? Are able to collide. Some will still collide with the vessel wall, and some will now be able to collide. And you should have more successful reactions. So by increasing the temperature, you give the substance more kinetic energy. And that means you have more collisions because substances are moving at a faster rate. Okay? That's the second one. The third one is concentration. Now here we have two substances in a beaker, right? And in the left beaker, you see a concentration of 3 particles. And on the right beaker, it's double that amount. So when you have just 3 substances, they're going to move in random order, okay? But they're going to move up, they're going to collide, and then one of them is going to, boom, react. All right? But when you double the amount of concentration, some of them is still going to move in random directions, but boom, you get a successful reaction. But then boom, another successful reaction. And you're going to have random motions. Okay? By increasing the concentration, you will have allowed more chances of successful collisions, so the rate of reaction should go up. Finally, we talk about catalysts. Catalysts are quite useful because sometimes when you want to increase the rate of reaction, especially for industry or maybe cooking at home as well, you would see that to make something into really cut something up to small pieces, that requires labor force. You have to require machinery to cut those things down to pieces. You maybe need a mill to mill everything down, and that requires money. Or you could improve the rate of reaction by increasing the temperature, but to heat something up, you require energy to go into to create that heat source, and that requires money because you'd be like burning more coal, or you'd be like basically burning more coal, or I don't know, burning something else, more methane, I guess, to just to increase the temperature. All right. Now, concentration, you can put more substances in there, but that means a lot of them are unable to react. And sometimes in the real world, things don't react nicely. And what I'm saying is that some of the substances may react with something else because of impurities or something like that, or the effectiveness of it, or it's maybe sensitive to exposure in the reaction vessel. We don't know, but you just add a lot of these starting concentration of this one of the particular substances, and that's going to cost you money, especially if you are unable to successfully recover those substances. So sometimes you can add a catalyst, and with a catalyst, theoretically, catalyst is quite nice because you speed up the reaction. And how it speeds up the reaction is quite interesting, because every reaction you need to have an input of energy. You need to put in energy to successfully form new bonds, break the bonds and form new bonds, and then create new products. And because you put in energy in here, this energy is what we call an activation energy. Don't really need to know it right now, but it'll be helpful in the future. Activation energy. Okay? And this activation energy requires maybe heat or exposing it to more surface area by allowing for more successful collisions to occur. And if the collision that occurs is strong enough, you can overcome the activation energy bump. All right? Allow the successful collision to occur, which means a successful production of the product. But catalysts will, in fact, when you add a catalyst, it will lower the activation energy curve. So maybe instead of going all the way up here, it goes down here. So by lowering the activation energy bump, you in effect enable collisions to occur more successfully, whether it's by this much collision force, this much collision force, they both will react. So there you go. The 4 factors that affect the rate of concentration. All right? Surface area, thermal temperature, concentration, catalyst, which also includes all the biological catalysts that we have in our bodies called enzymes. Right? So what is this unit going to do in terms of how we plot it graphically? All right? Here we remember we had our initial reaction curve. When you increase the surface area, you in fact will increase the rate of reaction. All right? This means more reactions get made up here as opposed to what is over here. What is over here? Right? If you compare the times, you will see that you have made more product here compared to that. With increased surface area, with the increased temperature, with the increased concentration, or with the addition of the catalyst, you will see that you make more products at a less amount, at a less given time. All right? So that is all we have for today. And in the class, you will be able to do several experiments that will illustrate this point.